Students, good morning. I am so happy to see you once again through this CETEL YouTube channel. Today's class is Flux, an important concept in molecular diffusion. In order to define flux, first let us consider a solution. Solution means it is a mixture of solute and solvent, or you can say that a mixture of compounds present in it. Components. Clear? That means solute plus solvent. Solution is nothing but solute plus solvent. I think you are very clear. Now, the information is, what about the concentration of components everywhere in the solution? If the concentration of the components in the solution is uniform everywhere, then there is no changes occur, there is no alteration. Uniform concentration, then there is no changes or alteration. Clear? Right. Unfortunately, the concentration of the compounds present in the solution is not an uniform condition everywhere in the solution. Non-uniformity in concentration. Non-uniformity in concentration. If there is an existence of non-uniformity in concentration of components everywhere in the solution, then the solution spontaneously brought into its uniformity by a process of diffusion. Clear? If the concentration is not an uniform condition, the uniformity will be resulted by a process of diffusion. Diffusion is nothing but movement of a compound or a solute from a region of higher concentration to a region of lower concentration. Diffusion is a process in which movement of solute from a region of higher concentration to a region of lower concentration. Clear? The movement or rate of movement at any point and in any direction. Rate of movement of solute. Rate of movement of solute or component in any direction, at any point, and in any direction, at any point and in any direction. This rate depends on the concentration gradient. What is meant by concentration gradient and what is meant by concentration difference? What is the difference between concentration difference and concentration gradient? Concentration difference means the difference between values at two extreme ends. Say for example, this is one point, this is another point. What about the concentration in this place? What about the concentration in this place? The difference in value is called as concentration difference. Concentration difference with respect to location or with respect to distance. What about the concentration here? What about the concentration here? So concentration difference with respect to distance is called as concentration gradient. Concentration difference with respect to distance is called it as concentration gradient. So what I am trying to say is the movement of solute from a region of higher concentration to lower concentration at any point or any direction depends on the concentration gradient of the solute at that point in and that direction. Depends on concentration gradient at that point and in that direction. Clear? Direction. Okay. So to provide a quantitative information on rate of movement of a solute, or to describe quantitatively we are in need of an appropriate measure of rate. Appropriate measure of rate. Clear? Once you are able to find the suitable method to find the rate of movement of solute, then it is okay. Rate can be conveniently measured in terms of flux. Rate can be conveniently measured in terms of flux, what you call the molar flux. Molar flux. Flux is nothing but rate per unit area. That means molar flow rate per unit cross-sectional area. So mass flux or molar flux. Flux is nothing but rate per unit area. While we are calculating molar flux, then it is defined as the ratio of molar flow rate to its cross-sectional area, unit cross-sectional area. This area is being measured in the direction normal to diffusion. Area is being measured in the direction normal to diffusion. Clear? Normal to diffusion. Okay, clear. How can I proceed next? So now we reach the concept of flux or molar flux. Molar flux is nothing but molar flow rate per unit cross section area. This area is being measured in the direction normal to the diffusion. Clear, right? Now let us consider a solution with two components. That means binary solution. Let us consider a binary solution. That means it contains two components, namely A and B. Component A and component B present in a solution. The solution is called as binary solution. Now, if the solution with a non-uniform concentration of A and B everywhere in the solution, both components must diffuse if the uniformity is the ultimate result. If you are tend to bring a uniformity, then both components must diffuse in order to reach the equilibrium condition or uniformity. Clear? In order to explain this, let us consider or let us use two types of flux to describe the movement or diffusion of A in a binary solution. We are in need of two types of flux. That means flux. One is flux NA, another one is flux JA. So we are in need of two types of flux in order to define the rate of movement of a solute in a solution of non-uniform concentration. Right? What is NA? That is flux of component A relative to the fixed location in space. Flux of component A relative to the fixed location in space. Clear? Right. This is the first flux. This is the flux of A, component A relative to the average molecular or average molar velocity. Average molar velocity of all components in the solution. Clear? We are in need of two types of flux in order to define or physically distinguish the rate of movement of a component A in a solution in B. One is flux NA. It is nothing but flux of component A related to the fixed location in space. Another one is flux JA. That means flux of component A related to the average molar velocity of all the components present in the solution. Clear? Now I am going to provide still more explanation. What are the two types of flux? Before that, this is very much important in application to design the equipments. This knowledge is very much essential to design the equipments. This knowledge is very much essential to provide the characteristic nature of the component. Characteristic nature of the component. Clear? Right. Say for example, let us consider water flowing in one direction. Assume that it is a river. See, this is the river. Water flowing in that direction. This is water. Direction of water. It is a river. In this river, fish swims upward direction, upward against the current of flowing water. So many number of fishes flowing or swims upstream. That means against the direction of water. A fisherman is simply sitting here. With a fishing net. This is a fishing net to catch the fish. Listen. Fisherman is simply sitting in the bank of the river to catch the fish with a fishing net. This is the fixed location. He is very much interested on the rate of fish swims upstream against the water, against the current of flowing water. The rate at which he is going to catch the fish by using the fishing net at a fixed location. Point number 1. This is fixed location. Rate at which fixed location. Clear? Another one is, what about the velocity of fish with which it swims upstream against the current of water flowing? It indicates the swimming ability of the fish. Clear? The rate at which fish will catch by the fisherman. This is rate. What you call the NA. The swimming ability, that means characteristic nature of this component. Characteristic nature of the component. This is JA. Clear? In today's class, I am briefly informed about flux. What is meant by flux? Clear? In this case, let us consider a solution. The compounds present in the solution, concentration of the compounds present in the solution, if it is uniform everywhere in the solution, there is no alteration occurs. Unfortunately, if the solution concentration is not an uniform condition, the solution spontaneously brought into its uniformity by a process of diffusion. Diffusion is a process in which a solute moves from a region of higher concentration to its lower concentration. The rate of movement of The rate of movement of solute A or component A in a solution depends on the concentration gradient at any point in that direction or at that point and in that direction. Concentration gradient is nothing but difference in concentration with respect to location. Concentration difference with respect to distance. Clear? Concentration gradient. In order to provide a quantitative description, we are in need of appropriate measure of rate. For that, we are in need of two flux. Flux is nothing but rate per unit area. Molar flux is nothing but molar flow rate of component A per unit cross section area. The cross section area is being measured in the direction normal to the diffusion. To discuss this, we are made of two flux. One is flux Na, another one is flux Ja. Flux Na is nothing but it is a flux of component A relative to the fixed location in space. This is the rate at which the fish catch by the fisherman by using the fishing net at fixed location. Clear? This is characteristic Ja. Flux Ja is the characteristic nature of the component. Flux of A relative to average molar velocity of all components. That means the swimming ability of the fish against the velocity of water. Clear? This is a brief information regarding flux in molecular diffusion. My next class is diffusivity or diffusion coefficient. Thank you.